Do you know the difference between abstract methods and virtual methods? Not just syntactic, but the difference in how we use them in design. Do you know that? In this demo, I will show you one aspect of using abstract and virtual methods you may have never learned right. Here is the future base class modeling a vehicle. The derived class car will be more specific. The base class will have a state common to all future derived classes, such as the make and the model. The first lesson you learn about inheritance is that derived classes must call some constructor in their base. Then comes the state that will lead to defining virtual methods. Is the engine running or is it off? The derived class will also add specific parts such as the driver's display. Please ignore my use of strings. I'm skipping modeling altogether because I want to show you the virtual members. Focus on the operation I'm about to define, starting the engine. I reckon that the base class will start the engine, and the derived class will switch the display on. That is why the method will be virtual. The car class does that by overriding the method. This is Object-Oriented Programming 101, overriding a method. Alright, I've done that, and I've made myself a bug. Calling the start engine method on the car instance will switch the display on, but will not start the engine. You will have known that an override of a virtual method might need to call the base implementation. Now the base class will start the engine indeed, and only then will the derived class turn on the display. That raises two hard questions. First, must I call the base implementation? What if I knew this override is complete, and the base implementation should not interfere? If that is so, calling the base implementation would be the bug, and omitting the call would be right. On another day, not calling the base implementation would be a bug such as the one I made here. That is so confusing. The second hard question is, when? Do we call the base before or after doing our part in the operation? Up to this point I have been making design mistakes. It's time to sober up. Maybe you have been learning programming wrong all this time. The books will teach you that we specialize a class by deriving from it and overriding its virtual methods. Well, wrong. I will now tell you my rule when designing base and derived classes. If the base class method makes side effects, then the class should not let derived classes override that, lest they might cause bugs of different kinds as you have witnessed. The methods that only return a result without causing side effects are less dangerous, and you can make them virtual. If you need a base result in the derived class, call the base and combine its result with your work. There is little or no room left for a bug there. I will now apply this specific rule in C# to my demo classes. Before that, let me tell you that you can learn much more about the basic operating principles of C# and object-oriented programming in general if you enroll in my course at Udemy. Use the link from the description to get a discount. You can also join me on Patreon and Discord, where you can ask questions about development in C#. By becoming a patron, you will get access to the source code of this video and all other videos on my channel, as well as a preview of the video course I'm producing right now. You can also subscribe to my channel and watch plenty of other videos I have made so far for free. Those were the additional learning resources. Now back to the demo. We acknowledge that the derived class will have something to say before effectively starting the engine and or after effectively doing so. However, the overall operation is causing a side effect, so we should not let the derived class override it. In C# we can make this method non-virtual. We cannot always prevent overriding in other languages like Java or Python. We use conventions to indicate our desires there. You will see it in a minute. The essence is that now the base implementation has taken the control back. It acknowledges that derived classes might have something to say before or after the core operation or both. And so we define two other methods with indicative names. These two methods cause no side effects in the base, so the derived classes can override them freely. You can declare them as abstract. That will make the entire base class abstract. Now we just make appropriate calls to the abstract methods and the method is complete. There will never be a bug in this method. Down in the derived class we must override these new abstract methods. This time the derived class has full control, switching the display on strictly after the engine starts. I must also override the other method, but I have nothing to do in it. Where is the bug now? There is no bug here anymore, thank you for asking. That is how the proper use of abstract methods improves the design. The abstract methods are extension points. Sometimes the class could define many such extension points, but the derived class might only need a few of them. You can make these methods virtual again, but leave their bodies empty. Choose whether the base class should remain abstract or not. The derived classes will become shorter, as they will only have to override the members they are interested in. Whether they called the base or not will make no difference this time. Neither is a bug, so it really doesn't matter. One last note and we are done. While this method was virtual, we had no control over its invocation. When the external caller calls on a derived object, the derived implementation will run, whether it should have or not. That is yet another place for a bug. But look what we have accomplished now. The main operation could add a guard clause and stop the propagation of a call made to it. We shall not start an engine when it is already running. The difference is that none of the abstract methods will be invoked this time. The base class is now responsible for making all possible implementations correct. There will never be a bug when deriving from this class, all thanks to abstract methods as well as virtual methods with empty bodies. Remember, a virtual method that returns a void is a liability. Leave its body empty in the base class or declare it abstract, and you will be safe from inheritance bugs.